Meet Liam. At the time that this picture was taken, Liam was 6 years old, and his interests included NASCAR, Pokemon, and camping trips to the Appalachian Mountains with his family. Unfortunately, Liam had an incurable form of brain cancer with an average survival of less than 9 months. I met Liam during my undergraduate training when I'd been studying the basic biology of childhood brain cancers. It was kids like Liam who inspired me to continue and expand my undergraduate research, first as a medical student and now as a graduate student. The reality is that Liam's story is not uncommon. Brain cancer is the second leading cause of death by disease in American children. Current therapies not only fail to treat all patients, as the case with Liam, but they're also extremely toxic in children and lead to devastating side effects like early strokes, growth failure, and mental disability. My dissertation research is on a promising new therapy for the most common type of brain cancer in children. The drug that I've developed targets a protein responsible for repairing a cell's DNA, or genetic material. You see, cancer cells grow very quickly, and their rapid growth causes them to have damaged DNA, which normal cells don't have. A certain amount of DNA damage actually helps the cancer cell by allowing it to mutate and adapt in order to avoid destruction by the body and by cancer therapies. However, too much DNA damage pushes the cancer cell toward its own demise. The way that cancer cells avoid excess DNA damage is by repairing their DNA. And that's exactly the process that's blocked by the drug that I've developed. My data show that the target of my drug has an important and special role in brain cancer. When I injected the drug into mice with brain tumors, I saw that the drug reached the tumors and caused increased DNA damage and tumor destruction that led to tumor shrinkage. What's more, the rest of the brain appeared to be completely unaffected, indicating that the drug is both effective and specific, and could possibly spare patients of the terrible side effects associated with current therapies. In addition, the data that I've recently published in the journal Development suggests that this new drug may work against the most aggressive and incurable form of childhood brain cancer, like the kind that Liam had. Altogether, my drug could potentially allow us to not only treat a greater percentage of kids with brain cancer, but to treat them more effectively. In fact, my results have been so encouraging that I've filed a patent on this drug and hope to move into clinical trials in the near future. My dream is to one day cure childhood brain cancer, and I believe that my research will bring us one step closer to achieving that goal.